my pleasure to introduce our webinar speaker this evening, Dr. Mario Binelli. Dr. Binelli is an associate professor at the University of Florida, is currently a member of the Beef Reproduction Task Force. So tonight, he will be discussing measuring and predicting pregnancy success in embryo recipients. So Mario, if you want to go ahead and start sharing your screen, I'll go ahead and turn things over to you.
Can you see my screen and hear me?
Yes, everything looks great.
All right, thank you. Good night, everybody. Thanks, Shelby, for that introduction. We'll have some information to share with you about measuring and predicting pregnancy success in embryo recipients. We have some concepts, and we also have information from a large study that we conducted for the last 2 years here at the University of Florida to address some of these points of the webinar tonight. So here's my contacts here will also be presented at the end of the talk. So if you please feel free to get a hold of me if you have some questions that I cannot answer today. Let's start from here. So this is Mr. Ralph Pelaez. He's a cattleman. He's a Brangus grower in South Florida, in Okeechobee. And it's one of those examples of it's amazing how much you learn when you have a conversation with these people that are really experienced and do a lot of ranching for a long time. He's been ranching since after he left school here in 1967. And on that conversation a couple of months ago, he mentioned another prior colleague, Dr. Alvin Warnick, also here from the University of Florida. And he told me that when he graduated, Dr. Warnick told him, if you have a fertile cow mating with a fertile bull, 2 out of those 3 matings will generate a calf. But 1 out of those 3 matings, for some reason, will not generate a calf. And that number, that 66, 65% pregnancy, is something that we are really interested in trying to understand. But perhaps more important, why do we miss about 1/3 of the pregnancies when we have a pregnancy opportunity offer to one of our animals? So, for example, you go to a ranch as your ranch or a ranch of a client, and you look at a bunch of good-looking cows like this ones, and maybe you wonder which one of these will be the ones that will get pregnant, which one of these will be the ones that will not succeed. And is that for just that one pregnancy opportunity, or is that something, a characteristic of an individual cow that she'll have more or less ability to become pregnant? So some of these issues and concepts we'll discuss tonight. So as you get started, the classical way we measure fertility or pregnancy performance is on a single pregnancy opportunity. So let's, for example, take this group of 100 cows that will receive timed artificial insemination. We'll be happy if we get 50% pregnancy by time AI when we preg check at day 30. Of course, we'd be much happier if we get even more, but this is a good baseline number, 50%. And then these 50% animals, they did respond to the protocol and were able to remain pregnant. Then there'll be another 20% of these animals that for some reason did not respond to the protocol. That's according to Salis. There'll be, for any reason, a failure to be synchronized. And some of the reasons could be dysfunctions in the hypothalamus, pituitary, ovarian, uterine axis. That can be caused by the products that you use, by the protocols, animals, perhaps issues associated with the breed, health, body condition, also the environment. Perhaps it's too hot to handle these animals, or handling stress because of untrained crew, or perhaps unskilled labor. Then there are 30% that did respond to the protocol, but did not become pregnant or did not maintain the pregnancy. And here, possible causes would be, again, dysfunction with gametes. If they were embryo recipients, problems with the embryo, or a problem with the reproductive tract. And again, possible suspects would be products, protocols, animals, environment, labor, genetic incompatibility. So whenever we have a issue with the fertility or with the pregnancy outcome with the herd that we're working on, we are always thinking about these different factors. But for a matter of this presentation, for the matter of that specific moments that you try to synchronize and inseminate those animals, you call those ones that became pregnant the fertile ones, and then the remainder the infertile ones. So some questions. What is the individual capacity to respond to synchronization protocols? Is that, again, a matter of an individual animal, or is that from that specific synchronization operation? Second, what is the individual capacity to remain pregnant from each individual cow? And then can such capacities be predicted? Very good. So for that, we'll start with this model. It's a model that is more appropriate for embryo transfer. So we will bypass the initial 7 days of the pregnancy, the 7 days after estrus, and go straight for embryo transfer. And we can propose a simple model to explain the pregnancy by embryo transfer as the effect of the recipient and the effect of the embryo, the effect of the uterus by embryo interaction. So perhaps not every embryo interact the same manner with every uterus or with every recipient. And then an error term, this E letter here, which will help us to explain whatever these other components of this equation cannot explain. So I'll describe an experiment. It was a very strong group effort with many people involved as students, mostly Cecilia. She's now a doctor and she's now a faculty at the University of Missouri. Ellie, she was a master's student and now she is a county agent here at Florida. And Abdul, he's currently doing his PhD. Plus many other collaborators. You can see his pictures. I'm not going to mention one by one, but without each of these individuals' help, we'll never be able to conduct this experiment, which I'll describe now. Also, we have collaborators from the private industry and also the major grant supporters from the USDA. Very good. So the experiment that we conducted, we used 50 prima pairs. So they all had a calf before, non-lactating, Bos indicas influence cows. They're all generously provided to us by the Deseret ranches. They came from a lot of very uniform animals, again, of the same age, and they're all prima pairs. On the day that they were early weaning their calves, they let us go to the ranch and handpick 50 of these cows, mostly based on our ability to go through the cervix, because that was going to be required for this embryo transfer experiment. These animals were synchronized using a CEDAR program of 7 days. Then we watch for heat. Okay, only animals that showed heat, this is showed here on day 0, were allowed to remain on the experiment. Let me back up for a second. This experiment, it had 8 rounds, and every round lasted 90 days. During this 90 days, we had a synchronization period, a gestation period, and then at the end of the gestation, which was terminated at day 45, we had a recovery period. So these animals would undergo uterine involution and then restart in a different round. So 8 rounds, every round 90 days, total experiments 2 years. So back to the synchronization period, they were synchronized and they were checked for heat. They were checked for heat using 2 systems, a collar system, which I'll describe in a second, and also a Estratec system, which was by visual observation twice a day. On day 7, and day 7 is exactly 7 days after estrus. If the cow did not display estrus in a window of 3 days, she was removed from that specific round and re-enrolled in a subsequent round. On day 7, we transferred 2 embryos. So they were vitrified embryos. They had been produced all prior to the experiment by Genus, which is a commercial supplier, from 3 commercial bulls. Commercial bulls meaning bulls that they would use them to make embryos in vitro, and they would be successfully transferred and produce offspring. So these 3 bulls, they were rotated in pairs. So every time we did an embryo transfer, we transferred 2 embryos from, for example, bulls A and B, A and C, or B and C. That was randomly rotated and transferred to cows, always 2 at a time. Again, previously vitrified, then they were expanded here in the lab of Dr. Hansen, and then we transferred them 7 days after estrus. On day 20, we collected blood, and we also ultrasound the ovaries, and that was our first pregnancy check, just based on vascularization of the corpus luteum. If the corpus luteum was vascularized, they were considered as pregnant cows. If the corpus luteum had a low vascularization, they were considered as open. Then on days 32, 39, and 46, we just conducted normal B mode ultrasonography to preg check. And on day 46, after that last preg check, they received in 2 subsequent days an injection of prostaglandin F2 alpha to terminate the pregnancy. And then the recovery period started, and it lasted for about 35 days, when they were re-enrolled and restarted on the subsequent round. So during the recovery period, we also pre-sync these animals, so they would be in a good stage of the estrus cycle when the synchronization started on the subsequent round. So I hope this was clear. So 8 rounds, all subsequent, every round was described just as I presented here, and every time the same 50 cows were used. Very good. For estrus detection, again, we use the EstroTech patch system to score them. So if the cows had a score of 2 or 3, they were considered in heat, and they remained in the experiment. They also used a collar similar to the ones they use in dairy cows, and then by the collar is connected to an app, and then we could know exactly in real time when these animals were coming in heat based on their activity, an increase in activity, or together with a decrease in rumination. So the combination of these 2 variables were fed to an algorithm, and that will point to us the moment that the cows started heat and finished heat. Our system was a 60-acre pasture, so they remained for the whole time on that pasture. The computer and the antenna to recover the signal from the collars are on that red arrow on the top on a building. Then the cows received feed every day at the same time on this on a little secluded area of our pasture. So every day, they would be on range to send the signals to the antenna, and then again feed the software and let us know by our phone app when the cows were in heat. This is just an explanation of the arrangement of the bulls. So again, we had 3 bull pairs. The bull pair 1 was formed with bull A and bull B. The bull pair 2 with bull B and bull C, and the bull pair 3, bull C and bull A. And those are randomly rotated around the cows. And on the different rounds, a given cow will always receive another bull pair, not the one she received on the prior round. So let's talk a little bit about the effect of the recipient on this pregnancy outcome equation that I'm showing here to you. So let's start with estrus expression. So there was an effect. So here are our 8 rounds from round 1 to round 8. And here's the overall. Our overall estrus response was 72%, and there was an effect of round. So initially, on the initial rounds, the estrus expression was lower, and then it increased and became constant or with very little change from round 3 onwards. Each of these rounds was associated with a season, not a a natural weather season, but for every 3 months, they were associated with either a warm season or a cold season. So, for example, on round one was July, August, and September. That's hot here in Florida. Round two is October, November, December. That's cold, and so on. So that allowed us to examine and measure if there was an effect of season for estrus expression, and there was not. So estrus expression was similar across both the cool seasons and the warm seasons. And then because we did each 4 rounds was about a year, we separated in year 1 and year 2. And here we did see an effect of estrus expression between the 2 years, in which it was lower in the year 1 compared to year 2. We can discuss a possible explanation for the effect of year, but it's likely highly associated with the handling of these animals. They were handled prior coming to our unit in very extensive system. And although we trained them and we adapted them for 3 months prior to the experiment, still the very intensive handling of these animals probably likely did suppress some of the estrus expression on some of these animals in the beginning, but they overcame that as the experiment progressed. Very good. So how about pregnancy? So remember, we only transferred embryos in animals that showed estrus. And then there was no effect on pregnancy per embryo transfer measured at the end of each round. So on day 46, I will show you the pregnancy loss in a little bit, but just as a matter of how well did they get pregnant, there was no effect of round. It was on average 59.5% pregnancy by day 46, which we thought was pretty good. But again, this is only considering the animals that received the embryos, which were the ones that showed heat. So as long as the animals were well synchronized and showed heat, that did not affect their pregnancy on a specific round and overall. Also, again, we could analyze them by season, and there was no effect of season. They were able to retain their pregnancy to the same extent, whether those seasons were cool or warm. That is online with previous data, in which there's not a lot of evidence for the effect of heat stress in embryo recipients, because the most sensitive period of moment of pregnancy for heat stress, of course, is the first week, which is bypassed by embryo transfer. And when you looked at the effect of years, there was also no effect of years. Well, we transferred 2 embryos, and I'm sure some of you are thinking, how about twins? So let's get that out of the way. We had 22 twins pregnancies as determined by our pregnancy diagnostic of day 46. This is 7.6%. So there was not a major incidence of twins in our experiment. Very good. So how about pregnancy loss? So this is pregnancy loss by the day of pregnancy check. We had about 17% pregnancy loss between day 7, in which every animal was pregnant. They received a embryo that was able to expand. So we consider them pregnant on day 7. By day 20, 51% of these transfer had lost their pregnancies. By day 32, 103. So that amounts for for about 35% loss between transfer and day 32. But then on the subsequent pregnancy checks, day 39 and day 46, there was only an additional 5% loss. So here's our 40% about pregnancy loss. Remember, it was a 59.5% pregnancy by day 46. So we lost about 40.5%. And this is how it was distributed, about equally until day 20 and day 32. And then a lot less after that 32 mark. Now we are very interested on individual cow fertility. And this design, because each cow had 8 different opportunities to retain their pregnancies, gave us a unique opportunity to study individual cow fertility, which is different from what is different from most of us do, which is just go for a single pregnancy opportunity, synchronize a lot of cows, measure pregnancy to that artificial insemination or embryo transfer, and come up with a number. And we never know exactly those cows that did not get pregnant. Is there anything special with them? And the ones that did get pregnant, was it luck? Any other moments? Would that be repeatable? So we were able to test that with this design. So this is how we separated our cows. So cows that were able to maintain the pregnancy 6, 7, or 8 times, we classify them as fertile. And those are 7 cows, so 14% of the animals. Animals that were able to be pregnant 3 to 5 out of the 8 opportunities, they were we name them moderately fertile, and they were 24, so 48% of the animals. Then we consider the animals that were only pregnant 1 or 2 times out of the 8 opportunities as subfertile, and there were 17 of them. And then there were 2 animals that never got pregnant anytime, 0. Now, please, and I'll go through this exercise, and we'll get some more information right now. But look, this is based on the ability of a cow that was synchronized to become or to retain or not retain a pregnancy. So this also includes cows that were synchronized but did not show estrus. However, this classification is relevant because, again, if you are in an operation and you synchronize 100 cows and only 60% of them become pregnant, you're not really sure. Sometimes you don't want to know if they were synchronized well, if there was a problem with the embryo, if there was embryo loss. You just go for that final pregnancy measurement. So this is what we have here. So this is a composite effect of the recipient based on its ability to respond to the protocol and the ability for the ones that did respond to the protocol to retain the pregnancy. Now, this is a little complicated, and I'll go through this with you a little slowly for this first time. So on top, you can see the first column is the number of each of our 50 cows. And then we have the pregnancy outcome for rounds 1, 2, 3, all the way to round 8. And we give a color according to the pregnancy outcome. So blue, we love the blue. The blue are the cows that were able to remain pregnant to day 46. The orange, just a few of them, were cows that were open on day 46, but they were pregnant before. Yellow for day 39. The green are for cows that were open on day 32. The gray are for the cows that are already open on day 20, and the blacks were cows that did not synchronize well. So based on the outcome of each of these opportunities, each of these 8 opportunities, again, we classified our animals according to the criteria I showed you before. So green, yellow, and red, meaning fertile, moderate fertile, and subfertile. So you can see the performance of each one of these cows on each of the rounds, and how with that composite performance, we're able to give them a score. Very good. So when you look at this classification based on total pregnant at day 46, this is how our animals were classified. Very good. This is a second way to classify these animals, which will not take in consideration as much the ability of these animals to respond to the protocol, because here we are only including the animals that were pregnant by day 46 divided by the rounds they were included, meaning the rounds that they showed heat. So now I'm only considering the animals that synchronized well. And to be considered here, they needed to have responded to at least half of the protocols that they had the chance to respond. So at least 50% of the rounds they needed to be present. So now our classification changes a little bit. So we have a few more of the fertile cows, as we can see here in green, a lot more of the moderate fertile cows, because they were able to, this is the same criteria. So if they're able to get pregnant at least 75% of the time, so 2 out of 8, proportionately, they were fertile. If they responded from more than 25%, but less than 75, they were moderately fertile. And then if they responded between 0 and 25%, they were subfertile. As you can see here in gray are the animals that were not included more than 50% of the rounds. So they were not considered in our calculations here. And you can see that again, that now the dynamics of this classification of these cows change a little bit more. Now here's a third way to classify these animals, and I, by my own criteria, I decided what would be a fertility classification according to industry standards. And I considered fertile cows that would get pregnant more than 65% of the time. So 65%, if you get that, you say, man, this is a great yield. So I consider those as fertile. Then I consider less than 40% as subfertile. You synchronize a bunch of animals, transfer embryos got 40%, you're not that happy. And then the moderate are in between. And here again, this time our classification will change again a little bit more. So again, depending on the way you classify, depending on the way you look at your data and what you consider more important, you can classify these animals by different criteria. So here's just all of them together. As I just mentioned, depending on the way you classify the animals, it will have different proportion of animals that you might consider as fertile, moderate fertile, and subfertile. This is the last way I'm going to be shuffling this data. I know it's a lot of colors here. So now I am classifying the data according to the rate of inclusion. So 100% means they were included in all of the 8 rounds. And then as you go down this column, less and less were the rounds that each of the specific cows were included. Here, there's the opportunity for us to take a little bit further look on how these individual animals behave. So for example, these animals here on the very top, they were included in 100% of the rounds, all the 8 rounds, and they were all fertile. They got pregnant 7 or 8 out of the 8 opportunities. So they synchronize well and then retain pregnancy as well. Another category would be down here. So they're also fertile according to the industry standard, but they are only included in 50% of the rounds. So they're interesting because they synchronize poorly. They were given the same opportunities, but they were only able to show heat 4 out of the 8 opportunities. But then every time they show heat, they got pregnant all the way to the end. So they synchronize poorly, but they retain pregnancy well. Look at this other one here with an arrow. It was only included in 3 rounds, but the 3 rounds it showed heat, it maintained the pregnancy all the way to the end. So this animal will be out there in your operation or the operation that you work with. Another classification would be here. So these animals, they are synchronized as subfertile. They did synchronize well. Look, they were present in 7 out of the 8 rounds, but they retained their pregnancy poorly. Although they were present, they were only able to remain pregnant all the way to the end in 2 out of the 7 rounds that they showed estrus. And finally, terrible, right? So these guys, they synchronize poorly and they retain pregnancy poorly. Those are the ones, of course, who went out of your herd because they're not going to bring you any money. Even given 8 opportunities, they didn't show heat, or when they did show heat, they did not retain their pregnancy. So they're out there right in the middle of that lot of 50 cows that I showed you. They all look great. They have precedence. They all had a calf before, but still they perform very differently to the management and to the handlings that we submit them to. Very good. This is just a view now. We're going to zoom out a little bit from our individual cows, but you still keep that initial classification, the number of times they were able to retain a pregnancy out of every opportunity that was given to them. And then here we can clearly see what happens in terms of pregnancy loss or pregnancy maintenance. Our fertile cows, they have very little pregnancy loss. They maintain it all the way to the end. Then as we go to moderate or subfertile, they have progressive pregnancy loss as we advance in our pregnancy checks, as they advance in their gestation. But again, most of the loss is finished in our system by day 32, and just a little bit more leftover loss remained to after day 32 of that pregnancy cycle. Then we're able to look at those individual cows. This paper is published. Please take a look. And then on this paper, we looked at many variables that were provided by that collar system, but also by blood samples in which we evaluated the hormone concentrations, and then also by measurements that we took from ovaries, like follicle sizes and corpus luteum, and tried to associate that to those fertility classifications that I just showed you. So here in the bottom is just the pregnancy by embryo transfer. Of course, this is by design. We made those classifications. So the fertile cows had a 93% pregnancy by embryo transfer, the moderate fertile 65.2, subfertile 34.14. This is based on the way we classified the cows after the experiment was finished. So first, let's take a look at were there any differences among the variables that the collar gives to us in terms of the fertility classification of animals? Are animals with different fertility classifications, can the algorithm from that collar give us any differentiation between them? And the answer is no. So for the peak activity, peak estrus, the heat index, this heat is heat estrus intensity, increase in activity, time to peak activity, estrus duration of the proestrus, they're all similar. They're not different among these cows with different fertility classifications. Then how about the follicle, size of the follicle and estradiol concentrations just prior to estrus? No, they are very similar. There was no difference among these variables. Of course, we would like to see some differences because then we could have some physiological explanations for the changes in fertility, but no, we didn't see it looking at follicles or estradiol. How about the corpus luteum on day 4, on day 7? And then progesterone concentrations on day 4, on day 7. Of course, we try to think that, animals with more progesterone at the beginning of the estrous cycle will have greater fertility. But that was not evident when we divide these animals. And remember, these are the animals that received the embryos. So they all showed estrus. The message here is that as long as the animal showed estrus naturally, of course, induced by a protocol, but not by any other hormonal treatment, it's likely that you're not going to see a lot of differences on these other variables. Now, when you synchronize them and you do timed AI or timed embryo transfer, then there might be shifts here and there because of timing of ovulation. But we did not see that here when we did allow the animals to show heat, and the moment of heat was very precisely monitored both by the EstroTech and the collar system, and we transferred the embryos accordingly. Finally, endometrial thickness on day -1, day 0, or day 4 were again similar among all fertility classifications. We do have a trend here for a little bit of a thinner endometrium on animals of the subfertile classification, but that was the only variable that had any hint of difference of these animals that have very distinct capacities to retain their pregnancies. Very good. So how about the effect of the embryo? And the effect of the embryo here is symbolized by the effect of the bulls, okay? Because the oocytes were from the slaughterhouse, from largely Holstein ovaries, because these embryos were produced in Wisconsin. And then, regardless of the bull pair, and that was by design, that was expected. We didn't want to see any bull effect on this experiment because we were focused on the effect of the female. And indeed, except for a trend of difference in pregnancy by embryo transfer by day 32, these bulls had very similar performances. So the effect of the embryo on this experiment was negligible on the ability of these pregnancies to be maintained. Very similar, regardless of the bull pair used. Of course, we don't have a measurement from one specific bull. That was not the idea of this experiment. But when we do them by pairs, this is what we can evaluate, and there was no effect of bull. Then finally, because we have these different classifications of recipients, and we do have different bulls, we had the unique opportunity to study and measure the embryo effect by the recipient effect interaction. And although there's no bull by fertility classification interaction, as you can see here, this is not significant. It is and there's no effect of bull, as I just showed you before. When we look at these numbers, and they are small numbers, it is very tempting to try not to overlook, for example, a 5/28 pregnancies compared to 13/28 pregnancies when we compare these two bull pairs. So what we can see here is that if the cow is fertile, it doesn't matter what is the bull that is used, the pregnancy will be high regardless. However, it looks like there's a hint, and again, there's no statistics here, but this is what the numbers are screaming at us and suggesting to us, is that if the animal the cow is subfertile, she might be a little bit more selective, and there might be bulls that will have a greater success. Look, this is almost 50% here when you use these bulls and subfertile cows, compared to when you use this bull pair combination here on subfertile cows, in which the pregnancy success was numerically lower. So this is just something for us to think about, that perhaps there is something like a bull by recipient interaction. It's just very different. It's very difficult to measure, but there's something there to be considered. Very good. Let's go to pregnancy markers and prediction. This was all that I had to tell you about my fertility equation. So here, we'll talk about initially about prediction using blood markers. And what happens here is that interferon tau, the hormone secreted by the elongating conceptus, is able to activate the expression of specific genes, ISGs, like ISG15 and RSD2. So interferon tau is able to stimulate their expression on lymphocytes, on leukocytes, that are on the general circulation. So we are able to collect a blood sample, isolate these PBMCs, these immune cells, and then by PCR analysis, measure the abundance of these genes, and then tell if these animals are pregnant or not pregnant. So, for example, this paper that we published a few years back now show that for pregnant animals in black, the expression of OAS1 or the expression of ISG15 on lymphocytes is greater if the animal is pregnant compared to animals that are not pregnant. So we are able to differentiate them as early as day 20 based on this PCR analysis of immune cells. And where does that come into that picture? So for example, we know from other labs research that perhaps high fertility pregnancies will have a more elongated embryo. They will secrete more interferon tau compared to subfertile pregnancy that might have a not as long embryo that will release less interferon tau. And this is true. So Moraes, for example, they showed that high fertility heifers had more elongated embryos, and they had a greater secretion of interferon tau compared to infertile and to subfertile heifers. So how do we use this the gene expression of PBMCs to predict pregnancy? So we collected samples on day -2, so prior to estrus, to serve as a baseline, and then on day 20 on animals that received the embryos and were expected to remain pregnant, collect the blood, isolated the PBMCs, and then perform PCR. This is the average of every animal according to of expression of ISG15 measured on day 20, so on that blood sample from day 20, according to the pregnancy status. So we can see that animals that were pregnant on day 32, they had a greater expression than animals that were not pregnant on day 20, but also animals that were pregnant on day 20, but were not pregnant on day 32. So this blood sample collected on day 20 will provide a lower expression values, even if the animal has a highly vascularized corpus luteum, but then will have lost their pregnancy by day 32. That expression level will be lower. However, if we try to predict pregnancy at day 46, what we see is that the animals that remain pregnant between day 32 or 46, they had great expression. Animals that were non-pregnant on day 32, they did have a lower expression of genes by day 46, but then the animals that were pregnant on day 32 but lost their pregnancy on day 46, they still had a great expression of ISG15 measured on day 20. So the summary here is that we are able to predict pregnancy loss, not predict, but to identify on average the expression values of animals that had pregnancy loss. They will have pregnancy loss by day 32, but not the animals that will have pregnancy loss between day 32 and 46 based on a blood sample that was collected on day 20. When you try to use the predictive ability of ISG15 on day 20, we'll have an accuracy of 82% to predict the pregnancy outcome at day 20, 88% to detect the pregnancy outcome on day 32, and 83% to predict the pregnancy at day 46. However, you can see the sensitivities and specificities, they are around 80s, meaning that you can 78% of the time make sure tell that the pregnant cow is really pregnant, and 78.7% of the cow be able to say for sure that a non-pregnant cow is non-pregnant, but then you will err in a great amount in both ways as false positives and false negatives. So there is a measure of prediction, but of course there are limitations, because you really don't want to have a false negative in which you tell a pregnant cow that she's not pregnant and then lose their pregnancy. But this is a measure of prediction that I show you right here. How about the ability to predict pregnancy loss between day 20 and 32? And we're just going to focus here on the left for ISG15, again, measure on that blood sample took at day 20. And we have an 87% accuracy, it's pretty decent. But again, because of not having a greater sensitivity and specificity, we would be reluctant to use this as a final prediction for what's going to happen in terms of the pregnancy outcome of that animal, just with that, based on that blood sample collected at day 20. Now, the expression of ISG15, if we just look at here at day 20, of course, it is greater in animals that are pregnant compared to the animals that are not pregnant. And we just took this sample, only considering pregnant animals, and we checked what was the expression of ISG15 according to our fertility classifications. And then what we can see is that animals that are pregnant all the way to day 46, but are from the subfertile group, they have a lower expression of ISG15 measured on day 20 compared to the other two fertility classifications. So that might be an indication that that subfertile animal perhaps is bearing a smaller animal, not as well elongated. It was capable to keep pregnancy to day 46, but it had an interferon tau signal of lower intensity that was reflected on the immune cells to actually express less of that interferon stimulated gene. And the predictive ability of that day 20 ISG15 to predict fertile versus subfertile cows, again, is on that 80% range. We have very good sensitivity. We're very good. We can be sure to say that our fertile cows are really fertile, but then we have very poor specificity on telling that our subfertile cows are really subfertile based on the expression levels of ISG15. We're coming to the end now. We also collected PEGs in blood to use them as prediction tools. We used the assay that was developed in Kai Polar's lab. He was the one making the measurements of PEGs for us in our samples. And here, this is PEGs measured on day 25, so during early pregnancy. So if the animals were pregnant on day 32 or day 46, they had elevated concentrations of PEG on day 25, compared, for example, to animals that were pregnant on day 20, but lost the pregnancy on day 32. By day 35, they already had lower circulating concentrations of PEGs. Again, if they had a pregnancy, they were pregnant on day 32, but not pregnant on day 46, the concentrations of PEGs on day 25 were elevated, so PEGs were not good predictors for pregnancy loss that happened between days 32 and day 46. When I tried to do the same exercise, and as you can see, pregnant cows had increased concentrations of PEG in the blood from days 25 to 39, while non-pregnant cows had lower concentrations of PEG. When you try to look at these animals and see the concentration of PEGs in the blood when we compared cows that were classified as fertile, moderate, or subfertile, there was no effect of fertility classification, meaning that if the animals were able to maintain the pregnancy to day 46, the PEG concentrations were similar regardless of the fertility classifications. Very good. So in summary, we're able to look at the uterus, the effect of the uterus, the effect of the recipient, and again, I showed you in a couple of ways as a compound effect of the ability to respond to the protocol and the ability to show estrus and retain the pregnancy after embryo transfer, or just if you consider the ability to retain the pregnancy just for cows that were able to show estrus. There was a clear effect of uterus, depends on the recipients, and they vary deeply among themselves on their ability to retain the pregnancy. We did not see an effect of bull, and that was by design. We did not choose bulls with different fertilities. We wanted them to have similar fertilities again because the impetus of this grant was to study the uterine effect. Then we're able to show that ISG15 was able to predict with some accuracy, with a good accuracy, the pregnancy outcomes and some of the pregnancy losses. But the other, I didn't emphasize, but the other ISG, which is called RSAD2, another marker, had a lower capacity to predict pregnancy and the pregnancy outcome. And then the PEGs, of course, they were able to predict to show they were differently expressed, differently abundant if the animals were pregnant but not pregnant, but they are not associated with the fertility classification of animals. So in summary, for the measurement of pregnancy outcomes, ISG15, RSAD2, and PEGs, they had a good ability to tell us what was it, to diagnose the pregnancy outcome. The fertility classification was only differentiated in terms of ISG15, measured on day 20. Pregnancy loss to day 32, we're able to predict it and to show differences for all the three markers. But then later pregnancy losses that will occur between day 32 and 46, these markers that we changed, they did not have the ability to predict these differences. So the implication here is that these pregnancy markers have a limited ability to detect pregnancy loss that will occur after day 32. Perhaps novel markers are still to be identified that will be able to give us an early detection of pregnancy loss that will occur later in time, but they were not these ones that we tested on this experiment. So finally here, as a summary, we mostly showed the effect of the recipients, and as a possibility comparing fertile to subfertile according to their ability to retain pregnancies, it is likely that the most fertile animals, they did have a more elongated embryo, produced more interferon. We could measure that based on the expression of IST15 on the immune cells compared to subfertile animals. But placental function, at least measured by PEG, concentration of circulation, were similar regardless of the fertility classification of the animals. What are the next steps? So this is Abdul. He just had his qualifying exam today. He's probably relaxing now. So we collected a uterine sample from all of these animals prior to embryo transfer. And we are measuring the metabolome, the transcriptome, and the epigenome of these animals. And we will classify this omics analysis based on the fertility classification of these animals with the hypothesis that the molecular composition of the uterus will vary according to the fertility of the fertility classification. And it remains to be seen if it will be if the molecular composition of the uterus varies according to year, according to season, and according to round, as we did for the other markers. So very exciting news to come, more at the molecular level, but this powerful model will help us to distinguish and to come up with perhaps some inside the uterus answers to those fertility phenotypes. So here are the main people. I mentioned them: Cecilia, Ellie, and Abdul, and a lot of other people involved on these experiments, but these three people are the ones that are most heavily involved on organizing, conducting, and analyzing the data here. And here are people from my lab, and Dr. Henson, Dr. Matiscu, from the vet school here at University of Florida, from the Beef Research Unit, and then many of our collaborators from other institutions that were highly responsible and involved in the data that we collected and the way you analyze here. So it is a thank you. I take my cattle now to the barn, and I'm here wishing to answer some questions if you have some. Thank you for your patience. Sorry if I went a little longer, but that's the whole story for you. You are one of the first people to hear this whole story full. So thank you for your patience. Thank you.
That was a great presentation. Thank you, Mario. Really, really interesting data. There are already some questions in the Q&A box. The first couple are, I think, some more clarifications on methods. So I'll go ahead and just get those out of the way. The first one was, did you only use recips from day 0, or did you use like plus or minus 1 day as well?
We only used recipients on day 0. Now that day 0 is the exact day of estrus as detected by the EstroTech or detected by the collar. So we use both systems. And we allow the 3-day of cows to show estrus to the protocol. So it was not on a single day. But then again, the embryo transfer, they were conducted 7 days after the exact date that the animal showed estrus.
Awesome. That almost answers one of the other questions too. So next question was, why did you use 2 embryos? And were they all of similar stage and quality?
Thank you for that question. So we used 2 embryos because we wanted to minimize the chance that the pregnancy outcome was going to be dictated by the embryo, by a poor embryo. So adding 2 embryos, it decreased the chance that that just a single embryo, because it was of bad quality, did not result in a good pregnancy outcome, not because of the uterus, but because of the embryo. So the big focus of this grant and this project was the uterus and uterine quality. So again, we transferred two because we wanted to minimize the chance that one bad embryo would dictate the pregnancy outcome. They are all, as we said, and to put that on the grant too, they are commercial embryos. So those are embryos that the company would sell to a client. They are all they are grades 1 and 2, and they are blastocysts and expanded blastocysts.
Um, Thanks. You already covered this a little bit, but I'll ask anyways just to make sure that their question gets answered. Did you take into account the timing of estrus expression in relation to the developmental stage of the embryos that were transferred on day 7? Specifically, was there any consideration of how variation in the onset or duration of estrus might influence embryo receptivity with the embryo stage?
So no, the answer is no. Again, the idea was what we asked the company was commercial embryos. We did not pay too much attention to any more details of the embryos. Of course, they had to be re-expanded on the day of transfer. If they did not re-expand, they were discarded. So only embryos that successfully re-expanded in the lab by a very competent team here from Dr. Hansen's, only these embryos were put in the straw and taken to the range for transfer. So again, no, we did not make any other differentiation of the embryos except that they were commercial embryos and that they would be able to re-expand. And again, keep that logic that I explained about the bulls. So always bulls from a different bull pair, they were monitored throughout the experiment.
Thank you. The pregnancies were ended on day 46. Do you have any thoughts about pregnancy loss in IVF transfers past that point? So from day 46 to 90?
Yeah, of course, and again, depending on the experiment, if people did have multiple pregnancy checks, you will see different embryo, the different moments and proportions of embryonic mortality. I'm not sure. So day 45 is not a day that people traditionally do preg checks. They do 30 and perhaps 60 when they are sexing the embryos. So perhaps yes, perhaps no, but I would not be able to say. It was interesting, though, that between day 30 and 45, very little pregnancy loss. Was there going to be another peak in pregnancy loss between day 45 and day 60? Again, I don't know. And depending on the experiment, maybe the answer is yes. In other experiments, no. Answer, I don't.
Yeah. Did you consider estrus detection when animals showed estrus on both the SCR and EstroTech? Did you have information on the proportion of animals that showed estrus on the SCR but not EstroTech or vice versa?
Yeah, good question. So if you want more details, please look at that paper. It's been published in Theriogenology this year. I'm also very glad to share. If you just send me a message, my email is here. What we found in summary was that every animal that was in heat by the collar by the collar system was also in heat detected by the EstroTech. However, there were a small proportion of animals that were in heat only by the EstroTech, and they were not detected by the collar. So the collar has a little bit greater of or maybe a little bit less. The algorithm is probably a little bit less sensitive to detecting estrus. And remember, this collar system was designed for dairy cows that are, like in a confinement situation, and we expanded their use to grazing beef cows. So of course, there are ongoing efforts to optimize that algorithm for the beef animal. So we failed to detect some estrus in some of the animals. It's interesting though that these animals that were only detected by EstroTech but not by the collar, they had much lower pregnancy outcomes. So so the pregnancy outcome, if you're detected by both, is more than 70%, and the pregnancy outcome if they were only detected by the EstroTech but not by the collar, is, if I'm not mistaken, 28%. So it was a better quality estrus if they were detected by both methods. And there was no instance in which the estrus was only detected by the color and not by the estrotech.
Yeah, that's really interesting.
Yeah.
Other question is, can ISG 15 be tested for at any other time other than day 20 to identify differences between fertility classifications of recipient cows?
Yeah, that is a good question. So we have a paper in collaboration from a group from Uruguay, and was released this year in a Journal of Dairy Science Communications. And what they did, they took a sample from the cervix of these dairy heifers, and you can see an increase in ISG expression in pregnant heifers as early as day 14. On day 16, then they are really different between pregnant and non-pregnant. And by day 18, again, they just continue to be very different. So as early as day 14, the average expression is greater if you take a sample from the cervix, but then there's some overlap. There's some animals that are pregnant based on a day 32 pregnancy check, but then they still have low expression by day 14. But by day 16 for sure. Now in the blood, people try to do it earlier moments, and it is reliable, differentiated on day 18 in some cases, but the best one is still on day 20.
Yeah, so the second part of that question that they asked was, is it possible to test a group of potential recips prior to using them and use ISG as a way to 15 as a way to identify cows that are maybe more likely to respond positively to embryo transfer?
No.
So along those lines, I think that
This,
gets it maybe how can we help identify recipients that are more or less fertile
yeah.
before, right, in the field beforehand?
Yeah, that's the $1 million question, right? So, well, I'll tell you an easy way and I'll tell you a hard way. So the easy way is estrus. So estrus behavior and then transferring embryos according to the right moment, 7 days after estrus, that goes a long way. You saw we got 60% pregnant by day 45. And if you go by day 30, by day 32, is very close to 70%. That's very high. It's very good. And a lot of that is because those cows were only received embryos if they were detected in heat. Now, you don't want to be checking heat. Everybody wants to be doing time embryo transfer. So you pay a little price for that, or you will start to include in your synchronization systems the use of an estrotech, checking heat, and eventually a collar, or other products that they will be coming up by different companies. So that's the easy way. The hard way is what we're going to do. So we are collecting that sample from the uterus on day 4, and we will know how is the molecular composition of the uterus inside the uterus prior to embryo transfer. And hopefully at some point we'll be able to give you a panel of markers that will help you predict, hopefully, which cows are from each fertility classification, or which cow will be more or less prone to maintain a pregnancy if you transfer an embryo 3 days later. So that probing is on day 4 and the embryo transfer is on day 7. So that's to come, but there's a long way to get there.
Yeah, that would be awesome technology to have for everybody. I think we're all excited for the research that you're doing. So
Thank you.
thank you again for a great presentation. That was really, really interesting data and some good information in the questions there. Thank you guys for attending this evening. If you didn't get to watch the whole thing or you want to go back and rewatch it, remember all of these are recorded. This will be up on the website and YouTube shortly. And all the past webinars are also there. So if you look back and missed one this spring, please go back and watch it. We do have one more webinar in our spring webinar series that will be on June 17th. I believe we will have Dr. Terry Engel and be talking about mineral supplementation and nutrition during that time. So we hope to see you guys all on June 17th. Have a great evening.
Thank you. Thank you so much, everybody. Thanks, Shelby.